Okay, so I guess I can start. My name is Boris, and today we are going to be talking about the basic principles that an Android developer should follow in order to build an application that would be scalable and to be durable, and the most important will be to support and update to the latest standards. So first, let's have a look at what Android is recommending to us regarding the best structure that we could do for our application. I will share my screen. Okay, I don't know if you're seeing my screen. Okay. Okay, platform says it's sharing, so I hope you see it. Tell me if you don't. So what we see here from Android as recommendation is a pretty simple structure which consists of several components. On top of it, we see the activity or the fragment, depending on your structure and your logic that you have implemented in the application. This component is used to provide to present the user with all the information required for the application, and also to provide for the user to interact with our application. After it, we see the view model. For those of you that don't know about the view model, haven't heard of it, this is one of the additions from Android. The idea of the view model is to keep the data that is needed for your activity or fragment and retain it no matter what happens. It also retains the data during, for instance, the fragmentary creation, if you switch from portrait to landscape mode or other any configuration changes. The view model has scopes in it, depending on how you would like to access the data and where you would like to have access to it. It fragment scoped, which means that this view model will be bound to your fragment, and since the view model is life aware, it bounds to the life cycle of the component defined in its scope. So if it's a fragment scope, it will be bound to the fragment. It will live as long as your fragment is living. It could also be activity scoped, which for the same reasons will be bound to your activity and will live as long as it does. What the idea behind these scopes is that, for instance, you might have several fragments in a single activity that are reusing some kind of data. In this case, instead of defining a view model for separate fragments, you could define one view model for your activity, and the data which you put in the view model will be available to all of your fragments, and it will appear kind of a singleton to your fragments because you have access to the same instance of the view model in all your fragments, since this view model is bound to your activity. So the view model is the layer that is keeping and helping us manage our data. After the view model, we see the repository. For those of you that haven't heard of the repository or are new to Android, the repository is the layer which is responsible to provide the view model with the data that it should manage. And in this case here, in the graph, we see that the repository has two branches. One is to node data source. This branch will be used when you have made sure that your application, for instance, has access to internet connection, has fulfilled some conditions depending on your logic. And the other branch is pointing to the model, which is your local data source. This could be your database as shown here, but in case you're not working with big amounts of data, you could also be using just the shared preferences provided by Android. This is the structure recommended by Android. So let's now switch. I've made a project which is pretty basic, but I've tried to show in it all this structure and different use cases of it, and also some cool things which I'll show you a bit later in the presentation. Let's go to the project. The project basically fetches some repositories from one of my GitHub profiles and displays them in a list, and tapping on repositories, just fetching the pull request for this repository and again showing them in a list. I will show you how this data gets managed through a view model and repository. So let's to the project. As you can see here in the project, I will first show you.
Interrupting. Are you sharing your screen now? Because it's not visible. Guys, can you see the screen?
Obviously can't. No. I'll try to start sharing. The platform claims I'm sharing, but obviously there is some problem because people aren't seeing my screen.
I suggest to restart the stream so you can just leave the room. And after that, you can enter again. People will still hear. So, or you maybe have problems with screen sharing.
I shouldn't. I haven't had any problems until now. I'll try to re-enter the room.
Okay.
Okay, let's try once again.
Okay, let's start again.
Okay, I have tapped the start share screen.
Okay. Which browser are you using now?
I'm in Safari.
Safari.
I could try to switch to another one, maybe Chrome.
Yes, the Chrome is better. Is working better. Try
Okay.
Chrome,
Okay. I'll be back in a minute. Then.
You can now start again sharing the screen so we can verify if it is visible. Yes, it's working.
Okay, cool. So I'll start from the beginning, but be a bit more quicker. So
Okay, you can start from the beginning. You can start
okay.
right now. Everything's fine now. Thank you.
Good. Thank you. So again, let's close this one. This is the. I hope you see my browser now. This is the structure that Android is recommending for us to follow when building the application. On the top is our activity or fragment, which is the UI component responsible for allowing the user to interact with our application and tell us about what the user is doing with our application. It is bound to the view model. Once again, the view model is responsible for keeping the data that we are needing in order to provide a consistent UI to the user, and it's also responsible for maintaining the data between various configuration changes. The view model also is lifecycle aware, which means that it will live as long as the component which it is. So if we bound a fragment, it will live as long as our fragment is living, and will be like a singleton to this fragment. In case we have activity with several fragments in it which are using the same data, we could scope our view model to this activity, and it means that whenever we request the view model in any of these fragments, we will receive the same instance of the view model, which means that you have access to the same data in each and every fragment of this activity. The next level after the view model is the repository. The repository the data to the view model that it should manage and retain. The repository has the to where should it take the data from. As you can see, there are two branches. The first branch is taking it from a remote data source, which means from a backend somewhere. For instance, if you have an internet connection or other conditions that your application requires in order to fetch the data from a remote data source, if they're fulfilled, repository should check them and fetch the data from the remote data source. If these conditions are not fulfilled, then the repository is taking the data from our local data source, which in the picture here is a database, but it could also be, for example, the shared preferences provided by Android. For this presentation, I have made a project which basically is fetching the repositories from one of my GitHub profiles, displays them in a list, and tapping on any of the repositories from the list is fetching the pull requests related to it and is showing them in another list. And let's go to the project. You should be seeing my Android Studio now. Just verify. Okay, nobody. Okay, cool. You see it. Here, let me guide you through what I've used. As you saw the recommendations from Android, the recommended network manager that could be used is Retrofit. Retrofit for managing the network requests, parsing the responses, handling errors, and everything related to the network. Retrofit under the hood is working with HTTP network client to the network requests and receive the responses which Retrofit is handling. For dependency injection, I have used Hilt. Some of you may haven't heard about Hilt. Pretty sure if you have dealt with dependency injection, you have heard of Dagger. Hilt is around Dagger, which optimizes the work of Dagger and also removes some more of the boilerplate code, which was required by Dagger in order to work properly. I'm also using the Fragment Navigation library. This is also, let's say, newly added by Android. The idea is that the Fragment Navigation is a bit mirroring the iOS way of building the UI. If you have ever came across any storyboard in an iOS application. And of course, there's some testing libraries which come with the default project. So for the fragment navigation, I will show you how it looks. In this project, I have one activity with two fragments, one fragment to list the repositories and one to list the pull requests for the selected repository. So the fragment navigation configuration starts a file called navgraph. You could actually name it whatever you want. So basically what it does is to define first where the start of your UI, your screen chain is. You pass it the first fragment that should be shown. This is it. There you have an ID to identify this element. You have a name which points to the fragment class that will be used. You can pass to the tools library layouts, which is rendered here, but it's mandatory. And in the fragment, you have an action tag. The action tag is describing all the actions that this fragment could take. And by action, I mean navigation between the different things. So here we have only a single action because we have only another fragment. This arrow here is visually describing what the action is doing. Basically, the action is has an ID to identify it because we are referring to it in the code, and it has a destination which is pointing to another fragment where the action should lead the user to. And of course, previously we were using fragment new, where the arguments they were put in a bundle, the arguments of the fragment, and then when the fragment has been created, we are accessing this bundle and parsing all the arguments and using them. This is now simplified by just defining what kind of arguments this this fragment will be using. And when we are calling this action, we could pass this. The argument supports all the primitive types, and also it supports custom classes defined by the user. So how this nav graph then gets used? So in our main activity class, we have a super simple setup. I'm using the view binding and the data binding features of Kotlin. For those of you that don't know about them, view binding is a way to access the different UI components in your layout file without using the what we saw far, the find view by ID methods and so on, and adding more and more code. What we could just do here is from this binding variable, when we initialize it on the binding, we could access all the elements that we have in our layout file. In our case, this is only this nav host fragment, which I will now show you. So if we go to the layout file of the main class, we have only a single element there, which is the container view. This is the UI element that we should be using in order to take advantage of the fragment navigation feature. So what we have here, we are marking this. We should have at least one default navigation host view, because we might have different conditions leading us to different kinds of navigation in the application. So this project is pretty simple. So we have only it should take the configuration for navigation graph, which points to the file that I have showed you a couple of minutes ago. So basically, when we tell this component that its start destination is this fragment, the fragment container view is automatically making an instance of this fragment and is displaying it for us in the bound of this component here. So this is how our application starts. So here in main activity, as you can see, there is no code that is related, because the fragment container view is taking care of all the fragment instantiation and replacing in order for them to be shown to the user. So the first fragment we're showing is the repositories fragment. In the repositories fragment, what here is the same binding class from the data binding. We have one adapter. It's pretty simple one, recycler view adapter to just show the fetch repositories in a list. We have this inject annotation, which comes from the hilt, which again is a wrapper around Dagger for dependency injection. And we have the view model, which is the second layer, as we saw in the Android recommended structure. So we have the fragment on top, then we have the view model. This view model here is responsible to provide all the data that our fragment would require in order to work properly. In the onCreate view, we're just making an instance of the adapter. We're setting a click listener to it. Just when the user taps on a repository in the list, what we are doing is this method gets called as a callback, and here we are taking advantage again of the new fragment navigation feature. What we are doing is when we define our fragment here, and when we define an action for it here, this action in build time generates a class which could be used in our code. So if we go back to our fragment here, this action is actually the class name of this action is generated from the name of the current class it is related to plus the directions, which shows that the user will be going somewhere, and we are here as a method we are accessing some of the actions. In our case, we have only a single action defined, so we are calling it here, and in it we are passing the argument that is defined here that will is required for the next fragment at work. Which our fragment is a simple recycle binding. Instead of first finding it here, then in the onCreate we are using the find view by ID. We start using it. So this is the same. We are this is just simple item decoration, which is adding a separator between the different elements of the list. And this is the adapter related to the list, and I'm setting a repository adapter to it. Our repository adapter is just a list adapter who is receiving the repository, and it is binding it. So here, so we're creating the list in order to first to the folder creation. After the view holder is ready, we go on the bind view holder. These two methods are called for every list item. So here in the bind view holder, we're just getting the repository for the current position of the list, and then we're calling the bind method of the holder. The bind method of the view holder is taking advantage of the data binding. You should that there is a difference between the data binding and the view binding. The data binding is actually the view binding, as I told you, is taking advantage of accessing the UI components in the layout file directly the data binding is something else which allows us, if we go to this repo property, we go to our layout file for the list item. You know, it should be defined in order for Android to know how to show your data in the list. We have this data block here, which is used to define different variables. These variables again could be primitive types, could be string, boolean, float, or whatever. It could also be custom classes. Here in this case, I have defined the variable for the repository object that should be shown in the list. So we have a binding between our adapter and this variable, and another binding between this variable. And as you can see, I'm using it here in the code in our text view in order to just show the name of the repository. So just to recap, the view binding allows us to access UI elements through their IDs, and data binding allows us to access variables in the layout files through their name. What advantage these variables in this data block gives us, that if we are, for instance, like here, we are assigning the name value to the text property of the text. In order text, the only thing we should do, we shouldn't actually touch the material text view text property, but we could just go in our repository adapter, and if we would like to update it for some case, like there is a method because our repository has updated its name for some reason, what we could do, we just tab binding.repo, which is our variable that is bound to the text view, and what we do, we just say it equals new name. Let's say if this was a simple string that we are assigning here, assigning a new text value to it would immediately hit our UI that is shown to the user, and this change will be reflected right away. So enough of this adapter and our list item. So again here, the other thing that is really important is second method I told you about that I'm using. It's observe live data. So the view model that I told you is responsible for managing the data and retaining it when different configuration changes happen. Another thing that our view model provides us, let's go to it to have a look at it. What else it provides us is that it gives us the so-called live data functionality. The idea of live data is that it takes advantage of the reactive programming, which means that we are defining a variable, we are assigning a value to it, and from that moment on, we could subscribe to this variable in order to receive events every time it changes. So this is one of the main functionalities of the view model that are most usable. Actually, after we go through the whole structure, you see that actually saves us a lot of code for managing changes from different variables. And as you saw from the view model is bound to the repository. So the repository is the class that is responsible to provide us the data required by the application to be presented to the user. Again, for the wrapper around Dagger, we're using the constructor injection, which is also available in Dagger, to inject our repository responsible for fetching the GitHub repos from my profile that I have created for this demo. So if we go to repository, here it's again using constructor injection. It's injecting the activity context that I'm using here in the code. It also it's injecting a request manager class, which is a custom class that I have made, which is responsible for just making the network requests. for fetching the repositories and fetching the pull request for the repository name. There is nothing special here. And we have a class called local repository data source. So here in the get repositories method, which is used by the application to repositories from my profile, we have a couple of branches. First, we have a check if the user is connected, which is located in the base repository class. I'm using it as a parent of every repository that I have in my application, because the check for connection is will be done for every request that we are doing, a network request. So basically, the check connected is using the connectivity manager of Android to just tell us if there is an available internet connection, and it also has a method to handle the status code of the network requests. As you can see, I have defined a couple of errors here just to show you how it works. What is um, what is special here is this error message mutable live data that we are having. So the live data, it has two types. One of them is the mutable live data. This is the live data of which is a wrapper, our variable that we would like to use to. So basically, for our error message mutable live data, we have an error event which is wrapped around the mutable live data. So every time this error gets updated, which we could see here, as you can see, when a error is coming, we are assigning to the value of this error message different error depending on the case of the error. So every time this error message mutable live data, this is kind of like the uh, getters and setters that we're having for the plain Java classes. The idea is from the mutable live data, we are hiding this variable, so it gets updated only where we would like it to be updated. And because you see it's private, which means that it could be updated only from the base repository classes. I want this base repository class to be only responsive for errors that happen in the application. So when it gets updated, how do we tell the application that something has happened? We are using the live data, which is again around the error event. We assign it the mutable live data, because the mutable live data is a subclass of live data, and this error live data is then propagated. So then gets propagated up to, as you can see, we have first in the repository view model, we define another value, so we don't connect our repository to the actual UI component, which will be handling the error, because we would like to keep this structure where the activity or fragment knows only about its view models, and the view models know only about their repositories, and the repository and our activity and fragment are not connected with each other. This way we are defining a chain of responsibility where each component has its own job and should do its own job and not care about all the other components which are using the result of its job. So we are defining another variable which is targeting our repository error message, and this one we could see in here in the observe live data. At the moment our fragment is created, we could start observing this data, because as I told you, the is lifecycle. So as soon as our fragment is created, this means that our view model is also created and is bound to this component. So here we start observing the for that happened during the work of the user with this fragment, and when an error happens, we're just showing a simple snack bar with some message. And the other one is the repository slide data, which means that every time we receive new repositories from a network request or a database update, we will receive an event here. We will submit the new list of repositories to our adapter and we'll notify it so that it knows it should refresh and show the new list. So how do we to this point here? Again, our view model, so we have the chain of responsibility, then it goes to the repository here. And what we're doing here is the repository's live data is connected to our local repository data source. How our local repository data source gets updated. As you know, every application that supports offline mode has its database or shared preference where it's keeping the latest data that is fetched from the in order to show the user in case the user doesn't have an internet connection, so that the user doesn't just see a white screen or inconsistent data. Our network request is here after the check for internet connection has passed. We are triggering the get repositories request from our request manager that I showed you a couple of minutes ago. And Retrofit, this is the way that Retrofit is working. You create a request, you enqueue asynchronous, and you're receiving a callback. GitHub format for return is in an array. So we are taking advantage of retrofit response parsing. I have defined a simple model here. GitHub returns a lot of data for single repository, but I just took these three. I will be using this ID as a primary key in our database, which I'll show you in a second. And I'm taking the name of the repository and if it's private or public. This method here to local model I'm using to convert our network model class to a model which could be persisted in the database because I don't want to connect the format in which GitHub is returning their response to the model which I have in my database, because in case GitHub changes their model and start returning the different data or change the names of their properties, I will have to either make a mapper to convert the network model to our local model, or I will have to manually parse it or set explicitly names for the names for the. So here we are making a request, we are triggering it, and we have two options here. On response is called every time we receive a valid response from the server, and on failure is coming when something in the network connection fails, for instance, a timeout exception or some kind of a failure, and so on. And I'm passing this to our handle status code that I show you a bit. That is passing events to our error message mutable live data, which is then observed in our fragment. So in our UI, when we are making a request and something happens with the request, we will receive an error on the UI, which will be presented to the user so that the user knows what's happening. As you can see, this is simplifying a lot the error handling, because our chain of responsibility is only in one direction. Everything goes down to the repository, and then using these events, we're passing event directly from the repository to the fragment without actually having a connection between the repository and the fragment. In the on response, we receive it when we receive a valid response. And here the response from Retrofit has this property which called is successful, and is successful. What it's doing is only checking if the response code of our HTTP response is between 200 and 299, because this interval here is exclusive, which are the codes for a successful response. In all other cases, I'm just again passing the the response code to the method from the base response from the base repository to show an error to the user. So in case our response is successful, what we are doing, I'm calling the local repository data source. As I have called it, this is our database where we're going to keep our repositories in case our user loses internet connection. It has a save repositories method where we are just passing the list of repositories that GitHub has returned to us. So let's go to our local data source. For our database, I have decided to use Realm. The recommended way actually from Android is to use the Room database. I don't have anything against the Room database. I have used it before. It works really well, and also it's a feature supported by Android, which means that it will last for some time. But I have decided to use Realm because I'm more used to it, because in our company, in 95% of the projects that we are doing, we are making both Android and iOS, and we tend to reuse components that are available for both platforms in order to be consistent in the workflow of the both applications. So I'm using Realm, and repositories is an instance of our database, and asynchronously we're just clearing out what repository we have currently in the database, and we are adding the new ones that came from GitHub. So the repository Realm is actually, as I told you, just a class which is mirroring currently the one that is coming from GitHub. But in case anything changes between the model that comes from the GitHub and our model, all the places in code where we're using it. So we are saving the repositories here. What is interesting here is this get repositories class, which result is assigned to the repositories live data, which if you remember, we are also observing here in our repositories fragment. The idea here is that our repositories live data is using the value of the get repositories method of our local data source. Here what we have is we're using the transformations class, which is taking object which is a live data and is mapping it to another live data object, which could then be observed in our layout, our activity, sorry, or fragment. So the get local repositories is only getting again an instance of our database and is fetching all the repositories asynchronously. And there is a live data method, which implementation is available in Android developers documentation. What this as live data is doing is that it is just making a connection between our database, the result that we have fetched from our database, and the live data class that we will be using to observe the data. So the cool thing here, which removes a lot of code to manage updates in our database, is that now every time we update in our database to our repository Realm, which in our case happens only when we call the save repositories, we will get an event which we will propagate to this method up to this live data, which as you remember, we are observing here. So every time our database gets updated, we will receive an event here. And as you can see, this update happens only with this code. We don't have any custom flags that we are passing through the view model, then to the repository to call them back so it propagates the result up to here. The view model provides us this functionality just out of the box, which have worked with databases and synchronization between remote data source and local data sources, know that this is saving a lot of efforts for us in order to have this data. I'm fetching the results, and when I take them, I save them in our database. This save in database is triggering the event, which goes up here. So we receive the list. Otherwise, what you might have noticed here in this repository that there is no method to fetch the data from the local data source, because we have only this check here. If the user is not connected, we are just returning from the method, and that's it, and nothing happens. So you might wonder how, if we don't have an internet connection, we will show our offline data. Another cool thing about the view model is that the first time you start observing it, it is returning, actually it's triggering an event as if something has happened with our data, which means that from the moment when we call observe live data and we call the observe of this repository's live data, it will go to it, it will check what its value is, it will reach up to here, it will see that its value is coming from the get repositories method of the local data source, and it will call the repositories method, which will fetch result from our local database. So this way we don't even have to write any logic to take the data from our database. We just tell our database that we would like to know of any events, of any updates to our data, and that's it. And from that moment on, we are getting all the updates that happen to our database. The other cool thing is you might know that having such listeners to a data might cause leaking resources. As I told you before, the view model we're using here is life cycle aware. So given that we have injected it in our repositories fragment without any scope, it will bound to our fragment, which means that whenever our fragment is inactive, whether the user has sent the application to the background or is in the process of killing it, or Android system is killing it, all these listeners will be detached, and we won't get any exceptions, as previously it was happening that the listeners were still active if our application was inactive, and when they were getting an event for update, it was trying to update the UI, which was actually not visible, which was throwing an exception for our application. It was crashing in front of the user, and this is a not good user experience. So the other thing is the other fragment. I haven't implemented. Actually, I have implemented just a default fragment. Since it has the same functionality of displaying a list of results, it could be implemented in the same way. So I won't lose any time to show it to you. We could just start our application. Let me just delete the previous instance that I was using. So when we start the application, we will go through the main activity. The main activity will trigger the fragment navigation graph, which will show us the repository fragment. At the moment of creation, the repository fragment will trigger a fetch of our repositories, and when our repositories are available to us, we will receive an event here, submit the list to our adapter, and refresh it so that it's visible to the user. Starting the application. The latest version of Android Studio already allows us to start our emulators in the Android Studio, so we don't have any separate windows anymore. The application is starting, and as you can see, I have 3 repositories defined in my profile. Here, this is just a representation if they are private or not. As you can see, this one is public. So if we this second and yet another repository, they're just dummy repositories, which doesn't have any pull requests. I've added them so that we have data in the list. The Java Todays is the repository of the current project. I will post a link for it when the presentation is over, so you can pull it and have a look at it. So if we tap on the Java Todays, what will happen is we will fetch the pull request. I have added some pull requests, then it request and the status. This one I have merged with some command, and this here open. So this is our functionality. Something that I wanted to show you regarding because the updates to the database that are automatically triggering and refreshing the UI might sound a bit how to say, like a magic. So I'll now show you how they're working. Here in the main activity, I have defined just a method to fetch the repos, which is basically triggering the get repositories from our view model, and is calling itself every 10 seconds. So this means that if I enable this code here, our application will fetch the repositories every 10 seconds. So again, if we go through the get repositories, it will reach our repository. If we have an internet connection, you fetch them from the internet, update our database. This database will be propagated up to here where we update the list. I have also added some logs so you could see that it actually works and how it is working. So I stop it and restart. Yes, error. So it is taking the repositories from the local data source because this is the moment where we are starting to observe our view model, which, as I told you, is bound to our database. Then it checks for the internet connection. It sees that the emulator is connected. It starts fetching the repositories from the GitHub. It has received the 3 repositories. It saved them to the database, and this log comes from our repository, where you could see that after saving the repositories to our database, we have received an event here, and we are updating the list. So what I'm going to do now is I'm going to, as you can see, every 10 seconds the logs are here. So I'm going to create one more repository in my GitHub. I have already prepared it here so that you see that when I create it, it will be fetched at the next network call and will be shown. Just wait for this to pass. Okay, passed. We are creating the repository. No. Okay, I think it didn't create it. Log me out. Let's see. Oh no, it created it. Okay, so as you can see, up until now, it was receiving the 3 repositories. We created one. So now it starting the repo fetch comes from the main activity here. So it's triggering the get repositories call. It's getting the repositories from the remote source. It's saving them in the local database, and as you can see, the save has triggered again our observable here, and is updating the list and our new repository. So this is a way to keep a consistent UI for the user without actually, as you can see in this class here is 76 lines, like 15 of which are imports and maybe 15 are just empty. So with around 30 to 40 use the Android so-called workers, where you could define a worker which is only triggering every they're working at minimum least 15 of interval in the calls. You can define conditions for it to trigger, for instance, if there is available internet connection, so on. And you could just pose this worker in the background to start every time you start your application. And this worker, again, will be fetching, in our case, the repository, so data in the database, and the UI will itself automatically without us doing anything else, without taking care of the lifecycle of these listeners, like attaching them in on start, removing them on stop, and so on. So these new components, which are all part of the Android Jetpack, are actually making our life easier to provide functionalities that are super basic for nowadays application and are required in almost every application. As you can see, this now happens with several lines of code in different components. We have a strict chain of responsibility, so even if something happens, it is really easy to debug it and define where the problem is coming from. And also with these new components, Android is doing a lot of the work which we were previously manually handling. Android is handling it for us. So this is pretty much the basic stuff that an Android developer should follow in order to build the future-proof Android application, because this architecture will stay here for a long, long time. It is pretty new. Android will be supporting it. In the future, they will be adding more and more stuff which are securing our application more and more. So this is, as you can see, also it's a pretty simple structure. It's just four layers to code, and as you saw, every layer contains just only the required business logic. Everything else is coming out of the box from Android. So now, let's see, where was this? Okay. So now I will wait for any questions from you in case the stream has a bit more latency. Also, you could find me. I'll drop my email here in case you haven't found it. That's my email. You can write me if you have any questions which came up after this discussion, after this event. I will be happy to answer to you, and I will a couple of minutes to see if there are any questions.
I think that people can email their questions right to you, or they can message you via the platform. So you can just say them bye and see you in the virtual lobby.
Thank you to all for coming to my presentation. I really hope that it was useful to you and that you have learned anything, or I gave it for something that you would like to learn. It was a pleasure for me. So I wish you all the best, happy holidays, and all the best. Bye.